Recording and moving.
Okay, so for number one, part A, we have done this problem before. No surprises. What might have been a little surprise is that you probably were expecting it's just a typical equation, just solve it. So I did throw you a bit of a curveball, but you guys knew what to do here. Just plug in the coordinates in for x and y into the standard form. So standard form is y equals ax squared plus bx plus c. Now, I didn't specify actually what form to use, but I mean, that would be the easiest form to write the equation in, right? Ax squared plus bx plus c. So you plug in 0 for x and 7 for y, you get c equals 7. That was a gift. That was super easy because once you got c is 7, the rest is smooth sailing, right? Plug in 2 and 11 for x and y, you get 4a plus 2b plus c, or 7, equals 11. And then you get a minus b plus c equals 14 when you plug in a1 and 14 for x and y respectively. Of course, c is 7, so now you got even simpler equations. 4a plus 2b equals 4, a minus b equals 7 when you replace c with 7 in both those equations. And then you can substitute. You can say a equals b plus 7, substitute into 4a plus 2b equals 4, work it out, b is negative 4. Once you get that, a equals 3, c is 7. Doesn't take that much work at all. Literally, this takes like maybe a minute if you're on top of the set. It's very simple. Once you have that, then you have the answer for c, and you're good, right? So you move on. And the point values of how you distribute the points are shown right there. Okay, keep moving. Matrices, that was pretty simple. I don't imagine A was a problem. Just distribute the 2, subtract, you're good. If you were off by a number or 2, I probably took off a half point, but if I took off more, let me know. I'll explain why. For part B, interestingly, some of you guys didn't answer the question correctly. I'm asking to find both CA, the dimensions of both CA and AC. Some of you just did CA, which is kind of weird because I'm asking for both. So yes, CA is not defined because you have 2 by 3 to 2 by 2. AC is defined because you have a 2 by 2 by 2 by 3. So if the inner dimensions match up, or the columns of the left matrix or the rows of the right matrix, it's good. Not good. C, just multiply it out. You have that right there. Some of you guys have had some trouble with that too. Just, rows by column. 1, 2, 5, 1, 1, 2, negative 1, 2, 0, negative 3, 5, 1, 0, negative 3 with negative 1, 2. Match them up, multiply, add, you're good. For number 3, well, for the most part, this is fine. I mean, the equations were good for part A. Now, for part B, this is where some of you guys messed up. Some of you guys wrote this on the, let me do this on Zoom. Some of you guys had this. So you need to do 100, 50, 30, 120, 40, 54, 150, 60, 70. Then you proceed to raise it to negative 1 power and multiply it to the other matrix. But here's the problem. You're not answering the question. What does the question want? When I ask for an equation, what mathematical symbol must be involved in the answer? An equal sign. Thank you, Jeff. If you have an equal sign, that's a problem. You're not answering the question. So you lost a point because of that. What you could have done, if you really wanted to get so far ahead and write the inverse, go ahead. You still got to say it equals your variables, right? Personally, I prefer this because that's how you get started. And then you move this over by doing the inverse. Sure. But if you're going to write the inverse from the give me an equal sign and the variable matrix on the other side. Otherwise, you're losing a point. C and D were pretty much the same thing. Actually, personally, I wouldn't have written that. I didn't write this question, but I would just said, just solve and be done with it. So C and D are pretty much the same thing. So pretty much if you got the answer right, you got credit for both C and D. So anyway, that's the deal with that one. For 4 was fine. Actually, I was really happy with this because some people struggle with these kind of problems. Those are the answers right there. 10 thirds, negative 1, and negative 5. That's simple. Remember, negative 4 plus 3 lines up with W. 3x plus y lines up with 5. 6 lines up with 6, clearly. 2y plus W lines up with negative 11. Once you get W, you can get Y, you can get X, and you're all set. Okay, the last page. I'm a tad bit at a loss with number 6. I am of the opinion that I'm just going to keep asking as number 6 until you guys fully get it. So maybe we just, it's kind of like, you guys watch like the Batman movies, like Dark Knight and Dark Knight? What was the one that came out there, Dark Knight? What was that one called? Dark Knight Rise. There we go. Sorry. Yes, of course. And you know that one part where like Christian Bale plays Batman? He has to get out of this giant pit. He has to climb, and he keeps trying. That's number 6. That is number 6. We're going to keep going until you claw yourself out of this. You're just going to keep fighting. So we're going to keep asking number 6 so you guys finally get it. The reason why this matters to me is that I don't know who's going to teach pre-calculus next year. I might teach it. Someone else might teach. I don't know. But the bottom line is that Actually, I do teach pre-calculus right now. And I expect this skill to be rock solid on pre-calculus. Because when we start doing trig, we'll do some trig in this class for sure. But when we start doing deep trig, and the algebra has to be fully rock solid, I can't have these issues. Because if you have these issues, you can't run the trig, right? So we gotta make sure this is figured out. What you gotta do is just multiply by c, because p happens twice, right? So you break those p's together, but in order to get those p's together, get rid of that c first by multiplying by c. Combine the p's, factor it out, then divide by c minus 1.
How does P get factored?
Because there's two p's.
Yeah.
Factor it out.
So
Of course you can, and then what's left behind, c minus 1. Because once off to the factor distribution,
yeah.
by distributing p, cool, I got it. Right?
Yeah.
That's what happens. Yeah. I thought 5 was fine. Now, to answer your question, Hunter, about skipping steps. So what you have to do is you have to show me you're plugging it in. Then you have to show me that, okay, great. These cancel. Those are the first things that cancel. Some of you guys were canceling things out too quick. Like you can't cancel these out just yet because you haven't got rid of this yet. You have to get rid of this first. So you guys are trying to be like, so you guys are consolidating all the steps into one. Don't do that. Don't consolidate all these steps into one. What you want to do is be patient with the process. Say, okay, well, that goes away. Now that goes away, and I get x. Same thing here. Okay, these go away. X plus 3 minus 3 and x. So I want you to be patient with your steps. Some of you guys are rushing. So that was, but for the most part, I think we're good with 5. I don't think we have to ask that again. 6 is like that Batman movie. We got to ask. You're stuck in the pit. You're gonna keep trying to get yourself out of it. Okay, fine for 7. That was fine. I don't think it was an issue. Actually, I think we're good there. I don't think we have to ask that again. But from a retake perspective, I think 6 I'm going to ask again. 4 was fine. That was fine. Maybe matrix multiplication. I don't know. Like I'm just kind of nitpicking a little bit. I think for the most part, I think you guys, this was a much better test than the last test. So overall, as a whole, but if you have any specific issues, just talk to me. So yeah, so we're good there. Let me just begin recording. All right, here we go, guys. Oh. All right, using logarithms to solve exponential equations. So now we're going to use logs to solve equations. There we go, I just said it. So logarithms so far. Let's talk about what we've done. There are 3 important log facts you've learned so far. Discuss these questions with your team. Let's not worry about that. So, well, here's what you've learned about logs. You've seen this, and you know it's the same thing as saying this. I don't know why it says 3 important log facts. I'm a little confused with that. What are the 3? But you know that's important, right? So I'll give you a good example. Like what if you have log base 2 of 8? What is that going to equal, guys? You guys remember? Hopefully, maybe. I don't know. It's 3, good. No worries. And it's 3 because 8 equals 2 to what power? Exactly. That's why that's true. Okay. So what is a logarithm? Right there. And how can it be converted to another form? Right there. Also, a logarithm is the inverse of an exponential function. So those are some things we could say about that. So I think we're good on part A. I'll give you guys a chance to copy all that down. What was that? Sorry? We're going to get there in a sec. I just did part A right now. Okay, part B. Let's switch colors for part B. What do you know about the logarithm key in your calculator? So there's 2 buttons. There's log. There's ln. Log has a base of 10. Called common log. This has a base of e. Did we talk about e? I don't remember. Okay, don't worry about it for now. We'll revisit it later. E is just a number that roughly equals 2.7. Oh, you can put it right there. Yeah. It's called a natural log. And also, if you hit alpha, window, option 5, it kind of looks like this, where you could choose any base. Choose any base you want. So there's a common log, which is like right on the left side of the calculator. It just says log. That's base 10. ln's right below it. That's natural log. It's called base of e, which is 2.7 roughly. It's called natural log. Or if you want to just choose your own base, just hit alpha window, and there we go. Okay, a lot of stuff here. The screen's very busy. I apologize. Any questions so far? All right, and then last bit. Let me clear this. For part C, what does graph log x look like? It looks like this. Point 1 comma 0. Point 10 comma 1. So yeah, that's how it looks. It's a reflection of y equals 10 to the x but y equals x. So if I drew y equals x, there you go. Right general equate, I'm not sure what that means. So just cross, I don't know what that means. So just cross it off. But the blue is the log. And the red is that. Okay. So I think I kind of went pretty deep with the old stuff. Any questions? Okay. Remember, it's the inverse of an exponential function, or 10 to the x for log x, when log is common log. Where do you do in the calc? We talked about it. What it is, the conversions, we talked about that. So I think now we're ready to do some work here. Marta was convinced there had to be some way to graph that on our graph calc. She typed in that. Okay, that's not going to work for us. That's going to be much different. So actually, let's do this in Desmos really quickly so you can see what happens. So let's go to Desmos. That's probably a smart idea. So y equals log 2 raised to the x power. That's interesting. Or log base 2x. And that I don't know how to, I have to go to the keyboard. I don't know the shortcut for that one. Functions. There we go. Yeah, totally different functions, right? One looks like a line, one is actual log. Yeah, good. Yeah, calculus weird. It's there. It's just it's being stupid. It's still going down. Yeah, that's what I did in Desmos instead. So anyway, let's go back to the notes. So show the two graphs. So part A, let me do that in green. So if you plug in 0, for example, you should get 0, I believe. And then the other one, if I do that in blue, think it looks like that. Yeah, kind of like that. There we go. So why is that happening? Well, here's the deal. That's not good. All right. That's like saying x equals 2 to the y power. Actually, switch the same colors. My bad. That's like saying x equals 2 to the y power. So if I plug in values for y, it's going to be somewhat exponential in nature, but the other way around where x, y are switched. Let's do the other one in green. That's going to be kind of weird. It's going to look like this. Y equals log. It's base 10, by the way, if you don't see a base. That's going to be like this. 10 to the y. That's really strange. It's a really strange situation, but essentially what happens is that this will become linear. Like if I were to plot points, like if I were plugging in, say, 0 for x, I get 1. If I get 1, I get log base 10 of 2. So if I plug in 2, I get log base 10 of 4, and so forth. It's kind of weird, but it just becomes linear. Great question. So here's, and this is where it gets a little too advanced. 10 equals 2 to some power. I think it's going to be, I need a graphic calculator for this one. Let's see if I did log. Let me think about this one here. What the heck would that be? If I did log base 2 of 10. Yeah, exactly. So 2 to 3.322 equals 10 to the 1 power. That's what happens. So you can actually, if I kind of get rid of all this here, it's a little bit advanced, but you could switch 10 to a base of 2. You could turn any power to any base you want. So 3.322y equals x. Y equals x over 3.322. If I actually go to Desmos and type that in, here's what's going to happen. Y equals x divided by 3.322. They're pretty much the same line, right? They overlap. If I turn on this off, see that, yeah. That's what's happening. So yeah, that's why it's linear. So anyway, that's what's happening with that one. So just don't get it confused. That's the point I think they're trying to make here. Okay, this is the part I kind of care more about. And then we'll do homework after that. Okay. Let's look at 690. So the work you did in 680 as a counterexample, it shows a general statement that is false. For each following log statements, use strategies to determine whether they're true or false. So it's basically true or false. We're doing true or false here. So you could use a calculator to work it out, but here's what I will do. They're not gonna be the same. No. Yeah, so this case here, that's gonna be 2. Yeah, that's correct, Jack. Thank you. You got it. Yeah, so those are not the same. So that's false. Because you get 2 equals 1/2, which is not true. So don't confuse that. That's the point they're trying to make here. Don't confuse that. Likewise with B, let x equal 2, so you get log 4. And let me punch in my calculator. I get 0.602. But go ahead, Hunter. Exactly.
What is that? What happens when you square a log?
We're going to talk about that. There's a property that, but I'm not ready to have that discussion yet. But we will talk about that. But those are not the same. So that's also false. Yes, go ahead.
What's the log?
Oh, I evaluated. I plugged in 2 for x. I evaluated it. So I chose a number for x and I just worked out each side to see what happens. That's what I did. Yes, go ahead. Yeah, so those are not the same. Okay. Now, C is going to be interesting. But so far, A and B are both false. Again, for A, the left side was 2, the right side is half, not equal. For B, I chose value for x, like 2, worked out each side, they were not equal. I got 0.602 on the left side, 0.091 on the right side, not equal. Sorry, you guys got it? Yeah, we're good? Okay. Now, what's happening here? For part C, again, let x equal 2. So you have log of 49 equals 2 times log 7. Let's work that out. Those are the same. My calculator said so. That's why. The calculator said so. There's a property. We're going to lead to that in a little bit. There's a property that we'll use. It will make sense, and just be patient. We're just it's all discovery right now. This one I don't think it will work either. Yeah, that will be one on the right side. Yeah, those are not the same. So I think what we're trying to help you clear up misconceptions to not confuse things. C is a true thing. A, B, and D are not true things. And so we're going to talk about this property on the next problem because I see they're talking about that. But only C is true. A, B, and D are not true. And we did it by discovery, right? We just plug in numbers or we worked it out. We saw A was true by A was false when we worked it out. We saw B and D were not true by plugging numbers for X. Also plugging numbers for X for C, but C did work. A, B, D did not work. Right. I mean, if you're going through discovery, this is the first time you're learning, yeah, that's always a good strategy for any concept. Plug in numbers, see what happens. Now, in the previous one, only one statement was true. Of course, that was C, right? Only C was true. Use different numbers to make up 4 more statements. Nah, it's not. You get the idea. Here's the property. It's called the power property of logs. They'll always be true. As long as so you don't put a base. What do we assume the base is again? 10, right? Yeah, they'll always be true. So let me give you a good example. What if I had log base 2 of 8 squared then 2 times log base 2/8. If I work out the left side, you should get 6. Work out the right side, I have 2 times 3. 6 equals 6. Yeah. When you have the same base, you're allowed to move the exponent to the front. That happens. You're allowed to move the exponent to the front. If the input of the log is a power. That's what's called the power property. You're allowed to move that, or you could roll it back. That is allowed. It's kind of like exponents, like where you have like 2 to the 3 power. Like you guys remember this, right? What would this be? 2 to what power, guys? It's the same kind of thing. It's the same kind of thing here.
You could look at.
Yes, correct. Yes, correct. So that's called the power property of logs, which we're going to use for solving equations a little later. Let's look at 696. Margie thinks she can use logs to solve that. No. Logs are used solve for x when x is an exponent, not a base. When x is an exponent, not a base. How would you actually solve that? Let me erase some stuff here. Yeah, you got to root it. Yeah. So what you want to do here and if you were to work that out, like 1.654. So you don't use logs. You eighth root. But for the next one, we do use logs. And here's what you can do. Before I'll take a little break here. I'll pause for a second. I'll clear my screen in the meantime. I'm going to set it up down below. Give me 1 sec here. All right. So here we go. You take a log of both sides. You can do ln or common log, totally up to you, or any base for that matter. But it's fair treatment because you're doing to both sides, right? Now, what happens to the x on the right side? Knowing what we know now about the power property, where does it go? Goes in the front. So now you got this. Oh, sorry, I meant to put x. My bad. Let's use a calculator. Gets a little nasty with the decimals, but just deal with it. That's 1.04, my bad. .017. So there you go. It works because if I do 1.04, You do get 2. So it works. So that's how you use the properties to help you solve equations. We're going to be doing a lot of this down the road, especially when we're back from ski week. Yeah, go ahead, Hunter. Yeah, exactly. That's what I did. Yeah, I didn't show it. Sorry, but yes, right. That's what I did. Actually, I should have showed that. So thank you for bringing that up. If you do that in your head, I will give you an 8 for the whole semester. Actually, let's do it right now. Okay, if anyone can answer X right now in the next 10 seconds, you get an 8 for the whole semester. The one I just wrote in red, 1.568 raised to the X equals 4. 1, 2, 3, 4, 5, 6. 7, 8. You guys are not going to get it. Yeah, not going to get it.
Wait, well, hold on, I'm doing this in my head real quick. 3.03, 3.02, and 3.
Oh, come on. You got a calc computer. Yes, it's 3.028, yes.
I've got it in my head for 3.082.
Yeah, nice try. Okay. Excellent. Good. Let's keep moving.
Actually, it just popped into my head.
Yeah, good. All right. Let's keep going, guys. So here's what we're gonna do. Let's work this out. So I'll kind of tee this up for you guys, and I'll have you guys work it out in your table groups. Give my voice a little break here. So we'll take the log of both. So I'll rewrite the equation first. Okay. So remember, the X rolls to the front if you have a log. If X is an exponent and you have a log of that, it rolls to the front. So log 5. Okay. We're going to table group. Someone should have a calculator. I see like Charlie got one out. That's good. Maybe some of you guys have calculators. Work it out. I'm going to work it out too in 2 minutes. We'll share our answers. Right? You might need a calculator for some of these. C, you don't need a calculator. I think you could do C without a calculator. Yeah, C is super easy. What?
He sent out like a school.
Oh, okay. It's like, wow, you and Joel are tight, huh? What is that about? Let's see here.
I got it.
I just did.
Oh, yeah. Where's the log?
Okay, so those are the answers. I'll give you guys a moment. So what I did was I took log 5 and divided by log 2.25 for A. For B, I took log 10 divided by log 3.5 for B. C is just 2. And here I took the 8th root of both sides, which you should be able to do in the calculator. If you do 64 raised to the 1/8 power, that works. Or if you hit math, option 5, that works too for part D. But for parts A and B, you're just dividing both sides by whatever's connected to X, right? I know you guys can do that. Likewise for B, so. Say again? How do you plug one in calculator? Logs? Well, just type log. Logs on the left side. Do you see log on the left side? Yeah, log 5 divided by log 5 divided by log 2.25. So, yeah, very good. Yeah, yeah, you're good. Yeah, perfect. Good. Yeah. Yeah, it's line 2 things, so 2 quantities. All right, let's keep moving, guys. I think we're almost done here. One last thing, and then we're all done. All right, so here you have y equals b to the x. We take and write the equation of the function. Hold on a second. What's going on here? Oh, okay. We gotta figure out the equation. What do you think the equation is, guys? Yeah, it's me y equals 3 to the x, yeah. Because 3 squared is 9. So that'd be 1 and 0. I think you guys get the idea, right? And this would be 81, 729, 2187. Don't tell me. No, you can tell me. 65, 61. Okay. Yeah, whatever. That's what we got there. And what is the inverse of it? The inverse is going to be y equals log base 3x. Because when you do the inverse, you switch x and y, and then you get this. Okay. So homework's pretty short. If you want to knock it out, you probably can. Or if you just want to chill, it's fine too. Yeah, 697, 698. Yeah, just 4 problems. So it'll be due Monday. You can wait till Sunday night from the 25th. It's totally up to you. Or the morning of the 26th before class starts. It's all good. Yeah, and you guys just relax, enjoy break, guys. And yeah, and if you have questions about your test, actually, if you come tomorrow during off hours, I'll hand it back to you. Because everyone will have taken by then. So come tomorrow during off hours, I'll hand it back to you at lunch or whatever. So, all right, let me stop my recording.